All right, now in the recent years, it is seen that the question has been asking of you the concepts of probability and possibilities in permutation and combination. And that has already always been seen in 2023, 2024, which are your recent years. So let's get into some questions I found that will help clear the concept. Firstly, we'll do whole questions so there is more knowledge. Revision भी होता रहेगा. Anyways, find the number of different arrangement of the 8 letters in the word cocoon. 8 letters, so 8 factorial divided by repetitions. 1, 2, 3 times C is 2 times C is being repeated and O repeats 3 times. That is the answer. Moving on. Part B. Find the number of different arrangements of the 8 letters cocooned. First letter is O and the last letter is N. That means we need to fix these letters. So 1, 2, 3, 4, 5, 6, 7, 8. O is the first letter, N is the last letter. These cannot move, right? So fix them up, box them up. They cannot move about these positions. Any other thing else, but the rest of them can move. So 1, 2, 3, 4, 5, 6. 6 factorial. Any repetitions? Um, so 1 O has been used. 2 O's will still repeat, and 2 C's will still repeat. And that should be it. Yep, that's it. Easy question. And can someone tell me why I have not used a 2 factorial here to move these around? Because the examiner has fixed it that the O has to occupy the first position and the N has to occupy the last position. So that's a fixed condition. Moving to your probability. This is a conditional probability question. So if you have not studied that concept, I'll just tell you the formula. Find the probability that a randomly chosen arrangement of the 8 letters in the word cocoon has all 3 O's together, given that the keyword, the 2 C's are next to each other. Okay, so there are two conditions. First condition of the conditional probability. By the way, the formula is whenever you need to find a conditional probability, you represent it like this. Condition A, given that, condition B, a straight line like this means given that, equals to probability of A intersection B, which means A and B, these two events occurring consecutively, divided by the probability of only event B. Right? So that's the formula we're going to use. Okay, so let's make this more relevant to the question. So the condition before given that is A, and condition after given that is B. Okay, so condition A is all 3 O's together. So O's together, given that the 2 C's are next to each other. So these 2 C's are next to each other. Easy question. C's are also yep, C's are also together. So the formula becomes all O's together intersection all C's together divided by probability of C's being together. That's how we'll do this. So first, let's find the numerator. For the numerator, we will simply do one thing. We will put the O's and C's together and box them up. So 1, 2, 3, 3 O's, box them up. 4, 5, 2 C's, they have to be together as well, box them up. And that's 3, 4, 5, 6, 7, 8. So now inside the box I'll do nothing because the same thing will repeat. Moving them around has no point. So I'm just going to say 1, 1. Outside the box, 1 position, 2 position, 3, 4, 5. So 5 factorial. Nothing repeats and I'm good. 5 factorial is the numerator. The denominator, this is the numerator. So equals to 5 factorial divided by, let's change colors again. La 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 la. There you go. Okay, now we need to simply just only put the C's together. So for the denominator, put the C's together, only box them up. 1, 2, 3, 4, 5, 6, 7, 8. So this is one position, nothing inside the box because that's just 1 because 2 factorial divided by 2 factorial as they repeat. And outside the box I have 1, 2, 3, 4, 5, 6, 7. 7 factorial, 3 A's will repeat, that's divided by 3 factorial. And easily I have the answer. That's my answer. Simple as that. So this is how you go about conditional probabilities. Whenever there's conditional probability and you have to find the arrangement, simply go for this method, this formula, and just apply it normally as per the techniques you know of. Easy question, right? Moving on. That was question number one. Another question that has had concepts of probability. Let's do that. Find the number of different arrangements of the nine letters Andromeda when no consonant is next to each other. These are the consonants and they are not supposed to be next to another consonant. So I will occupy the universal separation method. First, let's separate out the consonants, the D, M, and R. D, N, M, R, D, M, and R. And what am I left with? I'm left with A, O, E, A. AOEA, right? All these can move about their own positions. So 4 factorial, and then the remaining positions for my universal separation method are 1, 2, 3, 4, 5. And out of those 5 positions, I have how many consonants? 1, 2, 3, 4, 5. So I have 5 positions. All 5 will be occupied by the consonants into all those letters can move about their own positions. So that's going to be 5 factorial. And by the way, in this 4 factorial, I have these a's repeating twice, right? So that's going to be divided by 2 factorial. And here, do I have anything repeating? I do have 2 d's repeating, so let's divide by 2 factorial there as well. Anything else? No. So that's my answer. The consonants will never be next to each other, right? That is the answer. Simple. Moving on. Part B. Find the number of different arrangements of the 9 letters in the word Andromeda in which there is an A at each end and these are not together. Different arrangements is my keyword, 9 letters arranged करने हैं. Andromeda, okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. A is at each end. They cannot move, right? They have to be at both ends. So just put them up, ax them out, fix them, right? There we go. And the D's are not together. Okay, so in these positions that I have left, the D's cannot be together. Okay, so let's ये दो D's साथ नहीं हो सकते. They are not together, right? They have not used not all. They've just said they are not together. Easy question. Let's go for the universal separation method again. So firstly, I'm going to remove 2 positions from here. Why? Because when I need to separate something through the universal separation technique, I only arrange the letters apart from the D's first. So let's do them. Alright, these are the rest of the letters which are A's are gone. D's are not yet considered for. So N, R, O, M, E. 1, 2, 3, 4, 5. Those 5 have been arranged. 5 factorial because they can move about their own positions. Does anything repeat? Nothing repeats. And multiplied by how many positions do I have I unlocked? So the D's that I have can occur here once, twice, thrice, fourth, fifth, sixth. So 6 positions they can occupy. Now, can someone tell me why I have not taken this position? Why I have not taken this position? Because there is a condition that there is an A at each end, right? So I'm going to do nothing about those positions. Only going to play within these bounds. So 1, 2, 3, 4, 5, 6. 6 positions have been unlocked. Only 2 D's will occupy these positions, so 62, and they can move around, but they both will repeat. So divided by 2 factorial, that just cancels out. And yeah, and by the way, any questions on why these 2 A's are not being moved around? Because I will go for 2 factorial and I will they will form the same arrangement and I'm supposed to give different arrangements. That's just going to be divided by 2 factorial, can I cancel out. So your final answer is going to be 5 factorial into 6C2. Easy. See, this is how I'm supposed to occupy the universal separation method again and again. All right, now this question, 4 letters are 4 of 9 letters are selected, and now they haven't mentioned they want the different selections or they want the possible selections. So keep that change in mind. Of the 9 letters from the word Andromeda, find the probability. What does probability mean, guys? Possibilities. So essentially, when they've only said to find the selections, you know you're going to use combinations. When you select 4 of 9, already know you're going to use NCR. And now you know that you're supposed to find the probability. Favorable conditions divided by all outcomes, right? but the numerator will not have different selections. It will have the possible selections because it is probability. So keep in mind. I'll show you the technique on how possible selections work. Let's read the question. Find the probability that this selection contains at least 1D, and exactly 1A. Okay, 1A is compulsory, and at least 1D. So greater than equal to 1D has to be there. So 1D greater than equal to and exactly 1A has to be in every case I make. Let's make the case. Actually, before we make the cases, whenever it says possible conditions or possible selections, we need to first group whatever we have. What do I mean by that? Whatever repeats, put that in a box. For example, the A's repeat. How many A's do I have? I have two A's, so which means that one of these two A's will occupy that one position in every case, right? So whenever it says possible, I consider the outcome of both the A's I have, despite it being repeated. Okay, so put box them up. Now I have two D's repeating, so two D's box that stuff up. So that's A's and D's already put in a box. Then I have the rest of the letters, which is N, R, O, M, E. Box that up. This is just for your ease, by the way, so do that, it will help you out. Now, whatever case I make, I will think about selecting it from these boxes, right? For example, first let's make cases at least 1D, so 1D and 1A, 3, 4, 1D, 1A. Okay, so now where is this A coming from? It is being selected out of the two A's I have, right? I will not just fix this. Whenever it is possible selections, I will make sure both A's can occupy this position or both A's are thought of for a position, right? Because I want the repeats to be catered for as well. Now I'm not thinking, I do not want the different selections. I want all the possible selections. So let's think about this. Let's think about this D. This D will be taken from this box. Out of two possible outcomes, one position will be taken continuously. Another one A is being selected here. So out of the two, one will come here. And for the rest of these two positions, A's and D's have conditions on them. So they've had different boxes. And now for the ones with no condition on them, so I have N, R, O, M, E. I can simply go for these two positions. So 1, 2, 3, 4, 5, and that's 5, C, 2. There we go. That's one case. Now another case can be 1, 2, 3, 4. At least D's, right? So 1, 2, I can put two D's and still exactly 1A. And yeah, that's all. So two out of the two Ds I had in my box, both Ds have occupied these positions. Only one A out of the two I had. Multiplied and for the rest of the remaining letters. See, the ones that have a condition on them, you box them up and you think about them differently. The ones with no condition on them, you put them differently and select them differently, right? So now 1, 2, 3, 4, 5, 5, C, 1. Can I make another case? At least one D, there are no more D's, and exactly one A up. I think that this should be your answer. No more cases can be formed. So answer. So whenever it says possible selections and the things that have the condition on them, here I had the D's and A's, they had the condition on them. You put them in a box, right? And if the rest of the letters that remain, put that also in a box. Then whenever the case, for every case you make, whenever it's possible selections, you think about how many of those do you have, and then you select from that box. For example, I had two D's, so I select from that. I had two A's, so I select from that. And the rest of the letters I have five, which do not repeat. So I think about them differently for these positions with no conditions. And that's how you do possible selections. Now, I have already discussed the depths in the combination video, but I'm going to get into more detail, which is now think about this case. For example, now this case can already be made once with it. This D, this A. For example, I used. Let's go for a different color. I used this A. This A has been used, and this D has been used, right? So that is one case. But I can also make a case when the same D occurs with the other A, right? With this A. So both. So instead of one outcome that was different, I'm considering another outcome that repeats. This is the same thing, but it considers both of them, right? So that's another possibility. That's why it is called possible selections. See, so this is how we think about possible selections. All right, just one more concept remains. By the way, why do we multiply? If you want to get into that, it is why. See, this concept helps with that as well. See, in a consecutive case, in one case of all the four positions. If I'm not done with all the positions, I multiply, right? Consecutively occurring events, we multiply. And if it's a completely different case, we add. That's how it has always been. The adding of different cases, सबको समझ आता है. It's a very common thing. Everybody understands it. But this multiplication, what it actually means to multiply, it means that this D is considered with both the A's. The other D is considered with both the A's, and with every other letter that will occur here and here. To all those cases are added. See, multiplication is said to be the shortcut of addition, and that's the function of multiplying over here. That is just a little fun thing to think about. So let's move on to one final question, which is this one. I have the marking scheme for this one as well, so you understand why this is a very important question. Now, see, how did I identify when I have to go for possible, the possible selection way, when it said possible selections, or when it used the word selected selection and wants you to find the probability. Oh, by the way, probability ढूंढनी थी ना, रुक जा रुक जा, probability ढूंढनी थी. इसका जो भी आंसर आएगा, that's your numerator only, right? You need to find the probability. तो आंसर ये न्यूमरेटर हो गया, ये आंसर होगा न्यूमरेटर होगा, that this is the numerator, and the denominator will be all possible outcomes. Without any hesitance, just go for, you have 9 letters and 4 positions to occupy, go for 9C4 in the denominator without any hesitation. You need to find the probability, of course. So in these cases, I go for, in the numerator, when I'm considering the numerator, I will think about possible selections, and denominator I can go for directly. Now, to this question. Now, how there is a different distinction between factorial as well. See, almost always it will ask of you to find the different arrangements, almost always. But there are some cases like this one, when it says find the probability that a randomly chosen arrangement of the 9 letters in the word delivered has exactly 4 letters between the two Ds. Okay, letters between letters का case है, we can do that, no problem. But it wants the probability. मतलब it wants all the possible arrangements. And this is not selection. See, why? Because I have 9 available letters and 9 positions to fill. So I will use factorial. But I need to find the probability. Now, probability a conventional तरीका तो है. See, the conventional method is favorable outcomes divided by all possible outcomes. But that numerator, what will come in the numerator and what will come in the denominator changes when we are playing with factorial and as per the requirement of your examiner in the marking scheme here. So let me explain. Okay, so you have 9 positions, 1, 2, 3, 4, 5, 6, 7, 8, 9. By the way, this just requires me to put letters between letters, so I'm going to go for the second method which I taught in the techniques video. That's going to be, I'm going for the easier method, right? Just go for D here, 4 letters in between, so 1, 2, 3, 4. Another D can come here, right? Now, these D's are chilling over there. How many cases total? 1, 2, 3, 4. 4 cases total, so I'm going to multiply the arrangements by 4. Now, the arrangements is the real game. Let's look into that. Whenever it asks you of arrangements, as in using factorial, and probability, whenever those two are paired together, you make sure you do not remove the repeats. Am I clear? You do not remove the repeats. And I will show you exactly what a funny thing it is, but it's the requirement of your examiner, right? So do it as you would 1, 2, 3, 4, 5, 6, 7, 7 factorial for the 7 letters, right? And I know the e's will repeat, but I will not divide it because it's probability. Multiplied by one more thing. These two d's, they can move around, right? And the condition will still be met. The two d's have 4 letters between them. And I'll go for 2 factorial. Now I want to divide this and remove it, right? But I won't because I want the repeats to be part of this. So add a 2 factorial there as well. So, so 2 factorial into 7 factorial into 4. That's your numerator. I did not remove the repeats. Keep that in mind. And in the denominator, I will put in the denominator 9. All the possible outcomes are to be put together. So 9 factorial for them, right? Easy stuff. And here I will not remove the repetitive outcomes. So I will not divide. I will simply forget about it. Now let me show you what answer I get. So whenever it says probability and factorial together, you make sure whatever repeats, you make sure that it is part of your arrangements. Why are you gonna get to that very quickly and easily? And these are very rare questions and very specific questions, right? They're targeted very specifically, so you do not have to have anything to worry about. Divided by 9 factorial. Wait a minute, let me find the answer. Factorial into 4, if I'm not wrong. So the answer is 1 over 9 is what I'm getting. 1 over 9, right? And actually, let me simplify that as well. Wait. 2 factorial into 7 factorial into 4. That is 40320 ways divided by 9 factorial. 9 factorial is 6288. What is it? 3628. 362880. That simplifies to this, right? There is a reason for me to do this, and let me show you. Now, there is one more way you could have done it and gotten the same answer, which is the conventional method. How? We forget about probability being part of this. We just think about normal factorial, how it works, right? So let me use a different colored pen. 1 2 3 4 5 6 7 8 9. One D here, 1 2 3 4, another D here. How many outcomes? 1 2 3 4. So 4 outcomes total of the same arrangement, which is uh, 9 minus 2 7, 7 factorial. These D's will not move. I'm simply doing it conventionally. Divide by 3 is being repeated, right? 3 is being repeated. 1 2 3. Okay, good enough. And these D's are fixed. So 1 into 1, just for fun sakes, right? So that's just the numerator. And the denominator is going to be 9 factorial divided by whatever repeats. What does repeat here? What does repeat? What does repeat? 2 D's and 3's. So 2 D's, 2 factorial, into 3 factorial. Now simplify this. Before you get the answer, simplify this. This is going to cancel out this, right? Denominator, denominator. And this 2 factorial does not cancel out, but it will reciprocal upwards, right? Because something that divides, I am converting it into multiplication, and that's my reciprocal up. So if in a simple form, I can write this as 7 factorial into 4 divided by 9 factorial and into 2 factorial right here. So you simplify it and look, you've gotten the same thing, 2 factorial into 7 factorial into 4 divided by 9 factorial. But you will not do it this way. There's a reason here. Why? Because in the exam, you will most likely be going about it directly, right? Let me erase this right now. Let's just undo this, undo this. There we go. Now, if the examiner sees this, color into 3 factorial, and I have 3 factorial. The examiner sees this. Examiner will see, okay, the repeats have been cancelled out. So your numerator is going to give you 3360, and your denominator is going to give you, let me check, 9 factorial divided by 2 factorial into 3 factorial. It's going to give you 30240. And that is also going to simplify to, wait, let me check. That is also going to simplify to 1 over 9. The probability does not change over here. 1 over 9. The answer is the same, right? You're going to get to the same answer, but the examiner requires you. See, the examiner has made it compulsory that the total number of arrangements is found by 9 factorial only, and there is no division of the outcomes, and the denominator consists of 362880 instead of 30240, and the numerator consists of 40320, which will only be found if you think about it this way. See, the simplification gives you the same outcome, but if the examiner sees you that in the denominator you have divided the repetitive outcomes, he will subtract this 1 mark, which you cannot afford to lose. S1 is high, or it's a 55, it's a 50 mark paper already, right? You cannot afford to lose even 1 mark. At least I do not want anyone who has some or no interest, even no interest. You're working hard, you're putting in your time, and you're learning. And if you're anything like me, or if as something of a teacher, I like to think of myself as that. I do not want you to fail in that way, because itna kar liya and just that final stretch mein marks kate to maza nahi aayega na. We cannot have that. We're not affording that, right? So we make sure we understand that we do not remove the repeats whenever we have probability plus factorial. Plus factorial. Now keep in mind these are very rare questions. I will find more examples, and we will do more examples in the past paper. This was seen in the Feb-March paper. I remember this was a Feb-March paper. So yeah, it is something to be careful about. Same with possible selections, and same with conditional probability. The syllabus is getting harder and harder. I mean, they have made their syllabus they have made their test papers more standard and more tough. So these are things you definitely need to keep in mind. And now go on, fly, do the past papers as much as you can, and just kill this chapter. Because this is a compulsory question. It always comes in your paper, sometimes twice, sometimes once, and those marks matter.